All right, let's see all these inverse functions happening in our own lives here with a particular nice little example. So here I have a little right triangle here, PQR. It's a right triangle. I know that this side has length 5.4, this side has length 6, and our mission is to first of all find the length of this side and then find all the angles. Okay, well, there are lots of ways, by the way, of finding all the angles. There are different methods that you can use that actually all work. It's like so many things we've seen in geometry in our math courses. Sometimes there are lots of different ways of solving something. You should find the one that you feel most comfortable with. I'll show you one. So first of all, to find the hypotenuse, that seems really straightforward to me. What I would do is I would use the Pythagorean theorem. I know this leg, I know that leg, I can find hypotenuse. So here we go. I know that this leg squared, that's 6 squared, plus this leg squared, 5.4 squared, is going to equal the hypotenuse, which I'm going to call little q since it's opposite the angle, q. So equals little q squared. Okay, and now you solve this. You would actually square this out and then take the positive square root. I'll let you try that if you want, but we've all done that. And I'd see that q works out to be the decimal, by round, approximately 8.07. So this is 8 and 7/100ths. Okay, that's what q equals. Okay, great. So that was straightforward enough, right? We just use the Pythagorean theorem. I square this, take the square root of both sides, and I'm set. Now, what about the angles? How am I going to find the angles? Well, let's take a look at angle P and find that first. What could I do here? Well, since I know all the sides of this right triangle, I could actually use any trig function I want to produce a relationship. So let me just pick tangent. Again, you can pick sine or anything else. So tangent of the angle P is going to equal opposite leg over adjacent leg. So 6 over 5.4. All right, now here it's sort of peculiar because I know what the tangent is, but I don't know the angle. So I use the inverse tangent function. And so what that tells me is that P equals the inverse tangent of 6 over 5.4. Right? Let's think about that. P equals the angle whose tangent is 6 divided by 5.4. So how do I find that? Well, I can use a calculator. Let me just show you really fast. What I would do, I would just pick the inverse tangent, 6 divided by 5.4, and hit enter. And I see that P is approximately, I'm going to round here, 48 degrees. So P is 48 degrees. Now, you could use another trig function to find out the angle R, but I claim we're done because we have a triangle. We know the sum of all the angles is going to be 180 degrees. We know this is 90, which means these two angles are complementary, which means that to find this angle, all I have to do is take 90 degrees and subtract off 48 degrees, and I see 42 degrees. And so this is 42 degrees.